Do you think that these are the biggest challenges? We don't have the tools yet to make more fluid workflow or cooperation between these parts?
There are some challenges related to the tools. Of course, we have expected that up till now, when we are already talking about the digital transformation, some of these challenges will have been addressed. One of the biggest challenges is this interoperability between different tools, because you have to think in this way. You might have a big team of people working on the project, and then you can just split them in a different ways. You can just create small groups with the various disciplines, right? You can create big groups, which each discipline it's part of a group, right? And so forth. You can organize it in a different way. But to some extent, you still need to start sharing information between all the people working on the project. And then I think one of the biggest issue is this lack of integration. And then we think about the integration also because we talk about the interfaces between different disciplines. Let's talk about the interfaces between different tools. So how do we actually share information which is needed between different tools, right? And then in my perspective, sometimes I was loving IFC, but I think the IFC, the way it's created, is actually misleading. It was started like a kind of an interoperability format. Yeah, I'm going to start the war now. But IFC is not the right way when we talk about this interoperability between tools. You just need to have these interfaces where you just send the data you need to a different tool. Instead of actually spending time exporting. Imagine it's like, I can give you some example from my previous experience. For a 200 megabytes Revit file, when you export it, you're going to end up 8 times the initial size in Revit. And then I ask people from Building Smart, is like, why is that happening? It's like, okay, there are a lot of concepts which are kind of in that IFC format. And then, yeah, we don't know if we need them all or people are need them all, but it's again, it's like the one-click export of your file to an IFC format. It's actually cutting off or thinking or making us think that we are cutting off this need for communication and meaningfully defining what is the need of sharing that specific model with someone else. And maybe they don't even need the entire 3D model. They only need some other kind of information from there, some general information. But you just send them a 3D model and then they come back to you with a lot of questions asking, oh, why is that? Why is that? Maybe most of those questions are not so meaningful, but there is like, imagine you have a 3D model and then you just sometimes out of curiosity you start asking questions.
Are there any other potential formats that could be better than IFC?
I don't think there should be a format on exchanging this information. I mean, we all know that under the hood of all of our tools are some data models. And I'm talking about the data model, something similar to IFC, right? Imagine that you think of the IFC as a lot of lines of information or a lot of lines of text on which you have specific information related to that. It's the same happens with how the file is stored by Revit, how the file is stored by other tools like Archicad or Tekla, right? They all these tools have an underlying data model. And what you are doing, actually, you transform that data model to IFC. And then from IFC, you import it and transform it in Revit, for example. If you transform the model from Tekla to Revit, you have to go through this middleman called IFC. And I don't see the need of having that. It's just a way of defining well interfaces for most of the tools.
Yes.
Is defining is like once you have these interfaces, you just you can say, okay, I'm going to transfer this information to that specific tool, and then this interfaces needs to be standard because in the software development industry they already learned this on the hard way, right? And then if you think about now is how the information is exchanged between different services, it's just most of the time it's just JSON formatted, for example, right? And there's just let's say encapsulated in a specific request, and then just send it, and then you receive it. You get a response back saying you were successful. The other one gets the information they need, and it's done, right? So IFC in its form, it cannot play this role because it's too big. I know a lot of my colleagues, let's say from research, from academia, they invest a lot of time on, I don't know, expanding IFC, studying what's happening with the IFC and so forth. In my opinion, coming from the practice, it's just a waste of time. It's like the only reason you can export something to IFC if you want to just freeze in time different phases, the information, right? But then you can do it in the same way with the timestamp in a database in a schemaless format without following the IFC, and then you just retrieve it from there.
You know what is good? Because this will motivate people like you coming with better solution.
I mean, we see some efforts now, but I have none top of my head to give us an example of practice. But we see that the industry it's slowly moving to more, let's say, web-based solutions to support the design and engineering phase, but also supporting the operation and maintenance of the asset. So that's a good thing because you can handle easier in an easier way this kind of interfaces. And then probably I might add something more to this IFC debate, and maybe people will start their own debate on this. But imagine you create those models, right? To some extent, you try to embed some kind of intelligence into those models, right? And then we come back to the idea of parametrics, right? Parametric modeling, right? In the beginning, there's like the whole idea of the object-based parametric modeling. It's what Revit is doing. If you change the length or the thickness of the wall, it is actually going to update the stuff related to that wall, maybe distribution of the layers based on the thickness and many other things. We have this intelligence at the object level, and in some other cases we have it at the project level as well with more advanced cases, right? Imagine that once you exported that to IFC, you lost all that intelligence. It's like
PDF.
Yeah, it's like PDF, and then you send it to someone. It's like the way is like sharing a PDF with someone, and it's trying copying from the PDF to create a new Word document.
I heard these days in a meeting, someone said that PDF means permanently dead file.
Yeah, I think in some cases it's okay, but in some of the cases, yeah, it is the case. I mean, if you share that model with a specific purpose, I can give you different examples, right? So if you have an architectural model, which is like a 3D walls or maybe some information about materials to all the elements and windows glazing and whatever. If you share it with an energy expert who wants to run the simulation, he's just going to, let's say, format the entire model and reduce it to a set of surfaces and spaces and zones. And then have all that information just let's say, linked to those surfaces. Everything was related to the wall, including the thickness, is linked to that surface as a parameter, right? And the same with the structural engineering. I mean, I'm a structural engineer by background, right? And we all know that simplified stick model we are doing when we do the structure analysis. And it doesn't help us much because everything related to the architectural model is basically, in our case, reduced to loads. And you see how the stick model performs and what's the best section we have to put there, right? And then what is the purpose of receiving from the architect the entire 3D model exported to IFC when it doesn't fulfill the needs, right? And you see it is like, it starts from a really detailed model, which is usually the architects are doing, and then it comes down to the simplification, and the formula is discipline, is actually having in place to use the computers to support their effort doing the structural analysis or so forth, right? And then it can be easily simplified.
How?
It's just through these interfaces. It's like, okay, I'm sending this model to the structural engineer. We already know what the structural engineer needs to run the structural analysis. You don't need to export everything to, so you just send it as a flow of data to the structural engineer. He put it together, and
But
then,
how concretely will you do that?
well, you need to define these interfaces, and because again, you have this transformation from a data model to another data model, and then from one representation to another representation, right? Because if you want to use the computers to help us in our endeavors, right? We need to use specific formulas to how we see a 3D model or a wall, for example, from the perspective of a structural engineer, from a perspective of an architect, and we know that. There is practice out there that they are working with that, right? And then you just define it's like, okay, if I'm going to send this model to a structural engineer, then this is the information a structural engineer needs. It's just only the structural model. I mean, if you look in Revit, there are efforts on clearly defining this analytics model, and then imagine that usually what's happening, that analytics model you define in Revit is actually the base for doing all the structural analysis in another tool from Autodesk, which is robot structural analysis. And then you send it back with you calculate specific sections for your elements or whatever, and you send it back to the same model from which you got the information, right? So it's just this, like defining the interfaces. It's like across disciplines, across tools. You need to have these interfaces which will actually allow you, because we know what kind of data we send. It's just send it, and the other person is going to use
Are
it.
you working right
It's
now
like
on such a interface?
we had some projects on which we actually try to deal. I mean, I'm also talking from the experience as a software development in this way, because I took a model and then I had to transfer it to another tool, let's say from Revit to energy performance analysis. And then you just take them. I mean, if you look at in Dynamo, you might have different ways to export, let's say, to grab all the Revit file to export it to make this connection with different tools. So we can see nowadays, like Dynamo, at least for interfacing with Autodesk products, Dynamo BIM from Autodesk, right? So you have some packages which were written by some smart people out there, and then you can just take the Revit model and export it to different structural analysis software, to different energy performance analysis tools, right? So you just take the Revit model, and then through the pipeline created by these people, you just, without having the IFC as a middleman, and you just send it, and then you open it, it works perfectly, and then you do your job, you send it back, the result, based on the results, is maybe going to perform some changes and so forth. So this is the interconnectivity we want. Otherwise, having a middleman is just going to break the entire workflow. And we start talking about the concurrent engineering in our field. And one of the underlying issues with the concurrent engineering is that you actually need to share data in real time with the other discipline. So why should I overload? So as an architect, if I perform changes on a 3D model, why should I overload the structural engineer with sending him the whole model, and then sometimes asking him is like, oh, look for changes. It's like find the differences, the game, right? When you can just send it the simplified version of your model, will update it on his side, and then he will quickly understand what was changed, right? And then and the idea of this collaboration, because each discipline, each stakeholder will create their own models. It's also very important to have these well-defined interfaces, like when you define or define what you share with the others. Because once you change something in your model, you need to clearly see what you have to share with the others. right? So that they can update the model. Because if you're talking about the collaborative engineering and design, then you need to do that. Also, you need to have the tools in place to support that. And from my perspective, it's just a matter of development, because all the knowledge is there. We've been doing this for years, right? Sharing, trying to share stuff, but it's a matter of the implementation, having it there. I mean, you can get a structural engineer, an architect, and an energy expert in a room and say, okay, this is the model I'm using. And then you already have like each one will say the models they are using. They all now say, okay, this is the information coming from the architect usually. Then it needs to be transformed in this way. So then you have the interface, or you don't even need to transfer anything. It's like most of the times it's like the structural engineer, they will just create this stick model from scratch based on some characteristics of the architecture, like where the walls are intersecting, where are the position of doors and windows, and maybe some shape features of the whole building. So you create this kind of, and then we know as a structural engineers, we know that this is kind of iterative process. And usually the architects, they like the iterative process because they keep changing the position of the doors, windows, and walls. And then if you share only that information, which is actually as a basis for the input for the structural engineer, he can quickly update his model, right? You don't even need to send the whole model or the kind of, you just send the information they need.
Yeah, that makes sense.
And then it's just gonna, the whole information transfer probably is gonna be reduced to a set of 5-10 parameters, which the structural engineer can take it. But then you have the continuous flow between that, because if you change something, then you also want to have the structural engineer informed on your change, instead of having a specific meeting or a meeting especially set to communicate the changes from the architect. Or, you know, just like from my experience, there are two ways the whole idea of the communication and collaboration can go on the project. In some cases can be beneficial, but you really need to define where are these interface points between different disciplines. And in some cases, it goes sideways, and the people, they even forget what is the purpose of getting together, and they start talking about some random things in those meetings, and maybe some of them are not make any sense. I've seen meetings on which the architects start asking the structural engineer details about the structural analysis model. I say, how much of that stuff do you understand? In some cases, okay, it's important, but then when you start asking the details about what is this force at this base of the color,
now I need to get an architect on the podcast to defend everything you just said.
well, yeah. I mean, I love working with the architects. I mean, one of the things I actually like at them is like this idea of iterating and changing stuff. I mean, change is good. I'm a big fan of changing stuff in a project, right? But don't change after the project was constructed. Do it until we hit the ground, and know after we casted the concrete.